This is section 10.2b, part 2. We're still graphing quadratic inequalities, and inequality means it's going to be shaded. Just a reminder, as we look at this first equation, because it's greater than, we know it will shade above the graph. That's the first indication, because it's greater. Second, we know it will be a dotted line because it's not equal to. So we're just going to kind of remember that as we come back to the problem in a little bit. Now we're going to look at our values of A, B, and C. And see A is 1, B is 0, and C is -4. This is a lot like the problems in section 1. Whenever we didn't have a B term, if you remember, the axis of symmetry was x equals 0. So that's just something to remember there. If you didn't remember that, you could always go back to the formula, the opposite of B over 2A, and C, -0 over 2 times 1 is 0. So, as we're going to draw our axis of symmetry, I'm going to do it in color just because it's hard to see right on top of the y-axis. So there's our axis of symmetry in orange. Now, we're going to try to find the vertex. The vertex, remember, as we're looking for the vertex, we're going to insert the point 0 into the equation, and we're going to say 0 squared minus 4 equals -4. So 0, -4 is our vertex, and we go down 4 to find that. The remaining 2 points to find, we're going to have to plug in values to find the remaining 2 points. So I'm going to plug in x equals 1 for our first point. 1 squared minus 4 equals -3. So my point is 1, -3. From that spot, we can reflect over the y-axis to -1, -3. Now, for my final point, I'm going to plug in the value x equals 2 because I have not used that vertical slot in our points yet. So I have 2 squared minus 4, that's 0. So my second point is 2, 0. And I plot that point. That point as well is 2 away from the axis of symmetry, and so we're going to -2, 0. Remember, it's a dotted line. So we're going to draw a dotted line as we draw our graph, coming down through our points. And the shading on our graph, if you remember, it says it's shaded above. So we're going to shade everything above. That means all the points in the shaded section are solutions to the problem if you plug them all in. That concludes problem number 2. Let's look at problem number 3. -2x squared plus 8x minus 6. Once again, let's start the problem by determining what we're working with. Because it's greater than, that means it's going to be a dotted line. Because it's not equal to, it's going to be shaded above. So, in very similar way to our previous problem, it's still greater than and it's still shaded above. Now we look at our values of A, B, and C again. -2, +8, and -6. Since the B value is not 0 on this problem, we're going to have to find the axis of symmetry in the normal manner. That normal manner, remember, is to use the equation the opposite of B over 2A. So, we're going to plug in the value x equals -8 over 2 times -2, and get -8 over -4, which is x equals 2. That's our value for our axis of symmetry. So once again, I'm going to draw that with a dotted orange line. On that axis of symmetry lies our vertex. And our vertex can be found by plugging in the value x equals 2. So the question is 2, what? Well, let's see. We're going to plug in the value 2 where the parentheses are to find the value of y. Excuse me. Negative 2 times 4 is negative 8, plus 16 minus 6. Well, that's 2. So our point is 2, 2. We now are going to find the y-intercept as the next part of our graph. The y-intercept, remember, is 0, c. So that's the point 0, negative 6. So we very quickly can plot that on our graph. We reflect it over 2 units away on the other side of the graph, and now we're beginning to see our graph. It looks like it's going down. To find our fourth and fifth points, we're going to choose a value. I'm going to choose the value x equals 1. So if x equals 1, once again we're going to try to find the value of y by plugging it in to our equation. But this time I'm going to plug in the value 1. So now I have negative 2 plus 8 minus 6. Well, that's 0. So the point is 1, 0. I reflect it over, and there's our last point. I'm going to now draw my line. Once again, it's a dotted line, curving at the top. And this time it's once again shaded above. But now above seems to be outside the graph. So you can't think outside or inside. You really have to think above or below our parabola. That means any point outside in this shaded area is a solution to this equation. When we're graphing inequalities, make sure your dotted and solid lines follow the inequality appropriately.